Good evening. Today is Thursday, December the 3rd. Today in geometry, we looked at two concepts. One is the perpendicular bisector theorem, and the second is the angle bisector theorem. So I will share my screen here and show you some things that we did with each one of those concepts. So the first thing we looked at was the perpendicular bisector of a segment. So if I have a segment that goes like this, and I come in here and draw a perpendicular bisector, so like the perpendicular bisector would come down something about like this. Now, and what we're going to find out here, if I draw the line that connects the endpoint of this perpendicular bisector with each one of the endpoints of the segment, the theorem says that okay, so if I call this, and we'll call this point A, we'll call this point B, we'll point C up here at the top, and then down at the bottom here is D. Now DC is the perpendicular bisector of AB. Now what the theorem says is if point C is on the perpendicular bisector of AB, segment AB, then C is equidistant from the end points of AB. Now, if you go back and look at some of the things that we looked at with proving our triangles, see, I can prove triangle ADC. So we'll talk about triangle ADC is congruent to triangle BDC. I'll put the congruent symbol here. So here's my congruent symbol and the triangle in here. Now, if you look at what we've got here, see, I've got a pair of sides here. I've got my angles here, the 90-degree angles, and I've got this reflexive side DC right down through the middle. So this is congruent by side angle side. So that's a side angle side congruency. And what we have then is, remember, once we have established the congruency of these two triangles, there are 6 pieces of information in the triangle, 3 pair of sides and 3 pair of angles. I have used 2 pair of sides, AD and BD, and then CD and CD, and 1 angle. So the other things I can say are now congruent. So I can say AC is, so if I go back to my text here, I can say segment AC is congruent, I'll put the equal sign, to segment BC. And the reason for that is, if you remember, we had the expression a couple of chapters ago. We had the corresponding parts CPCTC. Corresponding parts of congruent triangles are congruent. So I know that AC is congruent to BC. I know that angle A is congruent to angle B. And I know that angle ACD is congruent to angle BCD. So that's the perpendicular bisector theorem. What it says is, if a point is on the perpendicular bisector, then it's the same distance or equidistant from the two endpoints of the segment. Now, the converse of that says if the point is equidistant from the two endpoints, then it is on the perpendicular bisector. Now, there are a couple of types of problems you can get here. For instance, if I come in here and say, okay, this point, this BC here is 9, then I know automatically that AC over here is 9, okay? Or if I come in there and I say that this, I tell you that it's on the perpendicular bisector here, that's what that gives us. And then the other type of problem could be, okay, let me see if I can erase some of this, or I'll just draw myself another triangle down here. So if I have a situation, anytime I get, let's say I have a triangle that looks like this, I'll draw this triangle here, and I want to draw like this, okay, and then I can say that, so I can come down here and say this is, okay, I can say this is perpendicular, and I can say that this and this are the same. Okay, and then I can come up here and tell you, well, let's undo that, let's do that, and let's do that. So let's say that I know this is 8, and this is 8. Then I know this line here is the perpendicular bisector, so I know that this part here is equal to this part. So if somebody tells me this is 4, it's got to be more than that. Let's say it's 5, then this part up here is 5. Okay? Now, we're going to take this one step further. So I will undo or erase all this now. Anytime I've got this, if you want to stop it before I erase, just pause it and look at what's there. Then I'm going to erase it and show you, okay, what do we do with this? So if we just go, same concept here, remember? So now what I'm going to do is I'm going to take and I'm going to draw a triangle. Any triangle, it doesn't matter. So this is going to be triangle ABC. So we'll put A here. We'll put B over here. And we'll put C over here. Okay. Now what we're going to do here is we're going to draw the perpendicular bisectors of each side of this triangle. So it looks like the perpendicular bisector looks about to be the middle. So we can draw this perpendicular bisector up like this. And then if we come over here to this side, let's see, that looks to be about the middle. And we can draw the perpendicular bisector there. And then if we come over here, this looks to be about the middle, and we can draw the perpendicular bisector there. Now, what's going to happen here, if you'll notice, when you do this, these three perpendicular bisectors are what we call collinear, concurrent. See, this is a right angle, this is a right angle, and this is a right angle. So now these three are concurrent. I'll write that over here. What concurrent means is concurrent lines are 3 or more lines that intersect at the same point. And this intersection point here is what is called the circumcenter, C-I-R-C-U-M-C-E-N-T-E-R, okay? That's the circumcenter. The circumcenter is created by the perpendicular bisectors of the three sides. Now, the reason why it's called the circumcenter, if I can come up here, let's see if I can find I want to draw a circle here. See? So if I've done this correctly, see, if I start here and just do that, if I start here, what you can find out is, let me see. Okay, I got a circle. Okay. So I can start, let's see if it'll do this. Yeah, okay, this way. We can do it this way. If I can do this thing correctly, see, I can pull that and I can pull, no, that's not going to work. Okay. All right. But what's going to happen here, let's just start it right here and go, it's going to move on me. All right, I'm going to try this one more time here. But what's going to happen is so let's just do it like this. Okay. Is the center, what you get when you do the circumcenter here, well, I'm just going to draw this freehand, okay? What you get, this center, it's the center of a circle that intersects or is circumscribed about the triangle, so it looks like this. It hits through each one of the vertices of the triangle. Now, if you have a software program like GeoGebra, so you can identify this, but what you find now is since the circumcenter is on the perpendicular bisector of each side, then this point is the same distance from vertex A as it is from vertex B, as it is from vertex C. So that's the circumcenter, and that's one of the two major things we talked about today. So if you do the perpendicular bisectors, they are concurrent lines. They intersect at a point. They will always intersect at a point, and that point is the center of the circumscribed circle. So, all right. So now that's the everything that we did with the perpendicular bisectors of segments, and in this case, sides of triangles. So now I'm going to erase this, and we'll go to a second concept, which is the angle bisector. So I'll get rid of this. Now, so when we do the angle bisector, well, we say if a point is on the angle bisector, then it is equidistant from the sides of the angle. Okay, so now let me show you here what this looks like. If I take an angle, so here's my angle, let's say something like this, and I come down like this, okay? Now, so let's say this is angle, we'll call this point A, we'll call this point B, and we'll call this point C. Now, so if I bisect the angle, then I come out here, and let's see, if I can kind of move this around, it looks like that's about the bisector of the angle, right? So I'm going to let that be point D right now. So if I pick a point on the angle bisector here, now remember, angle bisector means this angle and this angle are the same. And then what I'm going to say is, okay, if I draw the distance, if the distance from this point to the side is measured perpendicularly like this, and the same thing goes the other way. So what I'm saying here is that those two are perpendicular. So what I'm saying here is that any point on the angle bisector is the same distance from the two sides. So that means that this line and this line, or the segments, are congruent. Now, once again, if you try to prove, like let's say this is point E and this is F and this is G, now we can say that triangle BFE is congruent to triangle BGE. And once again, if you'll notice, the reason for that, see, I've got a pair of angles here, I've got a pair of angles here, and I've got my reflexive side here at BE. So this is an angle side congruency. Angle side. So now what I've got is, so then I've got the two triangles congruent, so I can say that FE is congruent to GE, segment FE is congruent to segment GE, and the reason here is that same corresponding parts of congruent triangles are congruent. Okay, so CPCTC, all right? Now, so that's the second theorem. Now, what we do with this theorem is we're gonna draw another triangle, but now in this case, instead of bisecting or doing the perpendicular bisectors of the sides, we're going to bisect the angle. So once again, take a few seconds here and look at this, and then I'm going to erase this, so I'll show you what we do with this. Okay, so here we go. Now we're using that same concept that the point on the angle bisector is equidistant. So now if I do this, see, I'm going to come down here. There's my first side. I can do, now once again, this does not have to be any special type of triangle. So what I'm going to do here now, I will take and I will bisect each one of these angles. So if I start here and I come out like this, let's see, I mean, I can, that looks to be about the bisector of that angle. Okay, now I can come up here and I can come down, and let's say that looks to be about the bisector of that angle. Okay, and then I can come down through here and draw the bisector of this angle. Now, and the thing about it is, once again, remember we talked about concurrent lines. So these three angle bisectors now meet at a point. Once again, the three lines are concurrent, and this point is what is called the incenter. So this is the incenter. I-N-C-E-N-T-E-R. Now, the reason why it is called the incenter is because now you have the center of the inscribed circle. So now, well, I'm going to go back. I'll do this again free-handed. But you have a circle that basically it comes right like this. It is tangent to the three sides of the triangle, and it comes, well, that's not very good. Anyway, it comes kind of like that. It's a circle, okay? So it is the center of the inscribed circle. Now, here's the type of problem that you run into here. If I say, okay, if I come in here and tell you that let's call this point J, and I tell you J is the end center. Now, what you know when I tell you J is the end center, you know that this angle is bisected, you know that this angle is bisected, and you know that this angle up here. So if I tell you that this is 23 degrees, then you know that this one here is also 23 degrees, because the end center is formed by the bisecting of all the angles. And if this one over here, let's say, looks to be about like, let's say 30 degrees, so then the one above it is 30 degrees, right? Now, and if you notice, see, the angles in a triangle add to 180, but if you take half of the angles, like each one of these is bisected, so this 30 here and this 23 makes 53, so that means I've got 37 left, right? So that means this angle right here is 37 degrees. Now, so what you can do here now, say if I set up a problem here, like if I draw myself here, I'll go back and do this with a straight line. If I draw myself a right triangle here now, see, then what I know is if I draw that right triangle and I come up here and draw this right here to this point right here, so the middle point is J, and let's say this is A, and this is B. Now, so what I know is that JA is congruent to JB because J is on the angle bisector of this corner down here. And the theorem we looked at a few minutes ago said if I'm on the angle bisector, then I'm equidistant from the sides of my angle. So those are the types of problems. Now, once again, I'm going to go ahead and stop sharing here. If you can freeze it and look at this if you want to, but I'll stop sharing now. What you need to do, you have your homework assignments on your Chapter 5 syllabus. If you don't have that, let me know and I'll send you a copy of it. But so try your homework problems, and if you have questions, send me an email. Let me know, okay, I'm working on such and such a problem on such and such a page, and I don't understand how to do it, and then I'll get back to you on it, okay? So I hope you're feeling better, and I'll see you again tomorrow.